before we get to the AI, we've got to go through the basics of Python. And before we see any code, the very first thing we should look at is comments. So comments are anything written after a hash symbol, and Python's not going to try and run anything within a comment. They're basically just used for explaining how something works. So in programming, it's useful to store different pieces of information in different formats. So for example, if we want to store someone's age, we want to do that as an integer, but we might want to store their name as a word. And we call these different formats data types. So what kind of data types can we include in Python? Well, we've got loads to choose from, and I'm going to go through a few right now. Some of them integers, floating point numbers, which are just decimals, strings, which is sequences of characters, words, sentences, paragraphs, lists, sets, dictionaries, Boolean values, and I won't go into more detail here, but just important to notice that Python comes with many different data types. And as we'll see later, you can even create your own custom data types. But right now, I just want to focus on the basics, so integers, floating points, and strings. Integer, number with a no decimal part, and a floating point number is a number with a decimal point. So Python is a dynamically typed language, which means that we don't have to specify the object type when we're creating it. Python's going to automatically infer what data type any particular piece of information should be. So Python knows that this number is an integer. And here I'm showing the first example of a function in Python called type. So under the hood, functions run a larger piece of code when they're followed by parentheses here. So this is known as calling a function. Here I'm calling the type function. And in the case of the call of the type function, it becomes equal to a value, which is the type of the value, which is given in the parentheses. So you can see here that the type of this integer is int. And you can use this function, which is built into Python. It's available anytime you're writing any Python code. You can use it to find out what type any particular value in your code is. And when a piece of code becomes equal to a value, we call it an expression. And if it doesn't kind of become equal to a value, we call it a statement. So expression and statement, probably two terms you'll hear quite a bit, and just important to notice the difference between those. So if a piece of code becomes equal to a value, we call it an expression. And if it doesn't, we call it a statement. So when I run a notebook cell, if the last line is an expression and it becomes equal to a value, then that's shown below the cell. Here, Python's showing that this is a floating point number. And in Python, you can perform arithmetic operations by simply using corresponding operators, most of them the ones you'd expect. So here we can add these numbers together. And you see here, just to point it out, print is another function. What it's going to do is simply print something to the output. And the output in the case of this notebook file is just the space below the cell. So that's what you can see here. And the print function is going to do this even if it's not an expression on the last line. So you can put these prints anywhere in your code. You can use them in Python files or notebook files. And if you want to be sure to print something, you should use the print function, which is why I like using it even in notebooks. And printing values so you can see them is a very first step in fixing your errors in Python. Printing values is the very first step in debugging your code. So I expect you see you put prints everywhere, especially if you're facing problems and you can't figure out what's going wrong. Just print things, take a look at what they are equal to, and then you'll probably see where the problem is occurring. You should be able to narrow down exactly where's there a problem. If you get an error, no problem at all. Just use those errors to find exactly what you're looking for. Find where it's going wrong and find them using the print statements. So we can also subtract in Python, as you'd expect. We can also multiply numbers together using the asterisk and divide using a forward slash. We can raise things to the power using a double asterisk. So this is 4 to the power of 2. And we've got two special division operations. Firstly is the remainder, which is represented by a percentage sign. This is 5 remainder 2. And floor division, which is represented by a double forward slash. Floor division is how many of the second value fit completely into the first. And operations in Python happen in the regular BIDMAS order, that is brackets, then indices, then division, multiplication, then addition, and finally subtraction. So notice the type of the output of a division is a floating point number. Let's also be clear that 0 is a number, but Python provides another type, which is called none, with a capital N, if we want to define the lack of a value. If there's no value there, we can give it none. With all of this, you can perform any arithmetic operation. One of the key things that we're going to need to do is save the results of these calculations. And we're going to do that by assigning variables. Assigning variables in Python is easy. Just take your variable name, put an equal sign on the right-hand side, and then put the value that you want to assign that variable to on the far right. When you're assigning variables in Python, you've got to follow some rules. Firstly is that the name of the variable you're creating goes on the left, and whatever's on the right, that has to be a known value. So for example, x is equal to 1 plus 2 is going to work fine, but x is equal to 1 plus y is not going to work because y is undefined. And x plus 1 equal to y is also not valid because on the left-hand side of the equal sign, this isn't a valid variable name. And once assigned, variables can be reassigned. They can be overwritten by doing just exactly the same thing again, setting that variable name equal to a new value. So as you can see, the first print statement outputs a 3, and then the new value is replaced by the updated version later. So here you can see me overwriting that. Python is a reasonably flexible programming language, but there are some rules and conventions that you should follow to just write good code, but also to avoid undesired errors. So 2 rules about variable names. Firstly, variables can contain numbers, but they can't start with a number. So this is legit, but this is not. And secondly, variable names can't contain any special characters. So I think I've got them all here. These are all the special characters. So you can't put these within your variable names. So some good code conventions as well, right? Just please stick to these when you're defining variables in Python. Use snake case. That means all of the characters are lowercased and the words are separated by underscores. I don't want to see variable names where it's a bunch of words all stuck together, or I don't want to see variable names with an unnecessary mix of capital letters and lowercase letters, and even worse here with the underscores mixed in as well. So never sacrifice readability for variable name length. A long, explicit variable name is always better than an ambiguous, succinct name. Avoid using some lowercase letters like L or O because they can be confusing whether they represent, a 0 or an O. Another thing is don't use Python keywords or the names of built-in functions as variable names, otherwise you'll actually overwrite them and then your program's not going to run correctly. So strings are another data type that represent text or a sequence of characters. They're represented with text enclosed by single quotes or double quotes. If you don't include the quotes, then Python's going to try and look for this as a defined variable, and that's going to give you an error. Strings will finish as soon as the Python finds a matching quotation mark. So for example, this has a few errors. Firstly, it's got a string containing what, and then this second single quote finishes the string. And what Python thinks now is that following that, you've got a variable named s, and after that, a variable named up, and finally an unmatched quotation mark. So that's going to give you a bunch of errors. So you can avoid this by using double quotes so that our string doesn't end where there should be a apostrophe here. Or you can place a backslash just before the character which we don't want to be evaluated as usual, and we call this escaping the character. And when you escape a character, you're telling Python to treat it as its literal value and not use it as it usually would. In this case, it would terminate the string. So now I'll just show a few of the things that you can do with strings to get you started. Commonly, you might need to concatenate 2 strings, join them together, and Python allows you to do that using the plus operator. So as you can see here, this prints out hey there all together, and there's no white space in between. So in Python, there's a bunch of operations that actually only make sense to perform on certain data types. So for example, it makes sense to capitalize strings, but it wouldn't make sense to capitalize numbers. And when this is the case, the function is part of the variable, and you can access it through the dot operator. We call these functions attached to variables methods. So here I can use the capitalize method, the upper method, and the lower method to get different versions of this string. Another common thing that you want to do is separate a string into different components based on a particular separator, and you can do this using the split method, which by default separates a string on white spaces. So notice that the output has square brackets containing each part of the string, which are separated by a space. And that indicates that we've got a list, which is another Python data type. You can also specify the character or word that you want to split on. So another thing that you'll commonly want to do is to set a different part of a string to the value of a variable. So that string changes if that variable changes. And we call this string formatting. The best way to do it is by using what are known as f-strings. In f-strings, the variable names or Python expressions are evaluated when they're placed within these curly brackets. There are other ways to do formatting, but f-strings are the only way you should be doing. They're modern and very readable. Don't let me catch you using the format method. So to finish off here, let's see how to get certain parts of a string. You can get a single element, which is called indexing, or you can get a range of elements, which is called slicing, by using square brackets. So let's see that here. Python's zero indexed. So the zero index corresponds to the very first character in this string. The index -1 is indexing not from the start of the word, but from the end, because it's a negative. And -1 corresponds to the last index. So note that the index 0 is the very first, but it's not -0, which is the end, it's -1. And slicing is where the start and stop index are given. So you can select a range of the string rather than just a single character. Slicing includes the lower bound, but not the upper bound. So if I index from 1 to 3, it returns y and t, but not o. So it's inclusive of the first index, exclusive of the last. And if you don't specify a lower or upper bound, Python assumes that the lower bound is 0 or the upper bound is -1, depending on which case you're looking at. So one reason why the slicing is inclusive of the first index and exclusive of the second is because you can do something like this. If I have a particular index and I slice up to that index, and then I add that to a slice from that index, then it's going to give me back the original reconstructed item which I've sliced. One final thing to note about strings is that they're immutable. So that means you can't change parts of them without reassigning the whole string. So this isn't going to work because strings are immutable. So here we've seen that Python has some different data types. So integers, floating point numbers, and strings. And you can assign variables with names to reuse them, whatever data type they might be. You can perform arithmetic operations in Python pretty easily. And you've seen that certain variables have their own functions attached. So we call those methods. And final thing I think we saw there was that you can index or slice variables using square brackets.